As the next step in our workflow, let's do a little computation using that line we defined in step one. And we're going to start by dividing that line into a series of curve definition points. The idea is we want to have a number of points along that line that we can then use for defining this new curve. And we're going to set that up using curve pointed parameter, using an integer slider to set how many curve definition points we want, and then use a code block kind of create the parameters. Now, the more curve definition points you include, the smoother the curve will be. So you get to kind of choose how many based upon just how precise you'd like that curve to be. Next up, we'll actually do some computations. This is where it gets a little bit trickier. We're going to go through and set up a formula where we have input sliders or values for the wave amplitude and the number of waves. Then we're going to use our sine wave formula where we're going to do the math sine of the definition points by the number of waves by 360 degrees. Okay, repeat the sine of that, then multiply that by an amplitude. So hopefully that'll look somewhat familiar to you based on our previous sine waves, but we're basically going to be for a series of different x values going through and computing different z values. Okay, so let's take a look at what that's like. So in Dynamo here, I can take my line and kind of pan on over so we can see better. Just feed that into a curve pointed parameter. I can choose how many different curve definition points I want to divide that line into. I'm going to choose 50 so I get a nice smooth curve. Okay, and you can see I got a lot of different points down there on the line now. Now those are curve definition points. And what we're going to do is going to evaluate each of those different points. We're going to go through and basically pull those different points to go through and compute a sine value for those different points. Okay, multiply that x value by the number of waves that we want in 360. That'll go through and give us kind of sort of an equivalent angle value that we can compute the sine of. Okay, then finally go through and multiply that by an amplitude. So it's kind of our typical sine wave function. So I'm going to take those x values from the points. Bring those in our definition, the parameters right there. So again, those are going to range from 0 to 1. I'm going to basically multiply that by the number of waves that we want. Okay, and that's now going to go through and have the number of waves times 0 to 1 times 360. And we're going to multiply that all together. The sine values so far will be, well, they're still null because we don't have an amplitude in there. We'll multiply that by an amplitude and kind of see what those values actually are. Let me change it to 1 just so you sort of get the sense of that. So as a starting point, those values are going to just vary from 0 to 1 or 0 to minus 1 to positive 1. Okay, kind of creating a simple sine wave. If I put the amplitude on there of like 4, the values are then going to change, kind of ranging from, kind of a positive 4 to a negative 4, something like that. Once we've gone through and, I've actually set up a nice watch node so we can actually kind of see the behavior right there. So now we've basically created our basic sine wave. Okay, we have our new improved z values computed. So as our next step, we're going to think about basically taking those new z values, combining them together with the old point values, okay, and creating a new wave based on those values.